All right. Is the recording working? Okay. So from the start, I downloaded FEBio Studio, and I figured I'd just walk through again some really basic steps to starting. So I just did new model, structural mechanics, and it gave me this setup. So first thing I want to do is import geometry. So whatever STL file you have access to. I have one of a vertebral body from a pig. It's just, cut off at the end of the vertebral body before the pedicles. So I figured I'd just try and do some basic simulation with this. So what did I do first? Um, Mesh over here, click the component. This doesn't seem to do much, but I meshed and it created a volume mesh, but it didn't really modify the element size. Like that's all still pretty fine. So I'm not exactly sure what MMG remesh means, but I set the element size to 5 and minimum to 2 and hit apply. And that you can see now the element sizes are larger. So for the purpose of figuring out what element size is good for you, something like this is probably fine. Like that looks like this. I'm not sure what the actual size will translate to for you, but um, that is how to change the mesh size. Next, I wanted to add a material. So we'll call this elastic. That's elastic isotropic is simplest. So let's go with that. I'll give it a Young's modulus of 20 and a Poisson ratio of 0.4. Sure, whatever. Maybe it needs a different density. No, it's not it. Not assigned. Okay. So yeah, the density didn't matter. So now we have to go to objects, which is our STL, and assign it to that part somehow. Part? Yeah, here we go. And we'll call that elastic. So it should be happy. It turned orange now. There we go. What else? Boundary conditions. So this is one way to add a boundary condition by nodes. So I'll call this anchor just because it's going to be where we anchor the nodes. So nodal boundary condition, zero displacement. So that creates this drop down here, which I can use to select nodes on, I'll select nodes on like the bottom vertebral end plate. Anchor nodes, maybe. Oops, I don't want that. I want, there's these three dots at the bottom that allow me to select actual nodes. So I'm gonna like hold shift and try and catch the edge. I'm just clicking and dragging to spin this thing. So let's say I just select a bunch of nodes on the bottom. It's not perfect, but maybe you can see there's some red dots on the bottom. They're kind of tough to see. But anyway, it selected those nodes on the bottom, and they're going to be the ones that we set to not move at all. So I hit plus, selection is not the correct type. Lovely. What does that mean? Try and add it without the extra name. Yeah, there we go. So I just removed the name and then I hit plus after selecting the nodes and it added that way. I don't know. Okay, so that handles holding the bottom of the vertebra down. Now we can try and add a nodal load. So we'll call that load, nodal load, nodal force. And then in value, they give you X, Y, and Z components of the force. So I'm looking at which way this thing is facing. The Z axis is like along the length of the spine, so I'm just going to give it like 50 newtons in Z. So that is a load object. It's not yet actually implemented. So now we need to tell the solver how to handle all these things we set up. So steps, add analysis step after initial. And this is step one solid. I don't think we need to touch any of this. It's telling us how the solver is going to address the processing of that load step we just applied, those 50 newtons. So it's going to take 10 steps. It's going to solve 0.1 or 10% of the time at a time to get to 1, which is when our 50 newtons will be fully ramped up. Let's see here. Load controller. Yeah, this actually shows the plot. So you can see from 0 to 1, the load ramps up to 100% of whatever the number we define as, which is 50 newtons. So I think this all makes sense more or less. I have to save the model. Sure. Let's see what it does. Tag unrecognized part list. Maybe it needs to be elastic solid. I'm gonna type default. I doubt that'll make any difference. Unrecognized tag. Ah, that's a new one. Don't think it's here. Oh, okay. Here's what we missed. Um, Getting rid of the correct node to apply the force to. So we just want to apply force to one node. Now it says items 1 instead of those previous 196 nodes, which were our anchor nodes. Maybe that had something to do with it. Nope, evidently not. Part list. Oh, it was because we originally tried to select the whole part as a selection for the kind of anchoring at the bottom. So that third selection here had an exclamation point next to it. So now I think we should be all right. Yep. So that's solved. You can see at the bottom here, normal termination. We can hit open results. Here's our lovely results. Let's see what happens when we hit play. So it's pulling on that single node that we applied that force to. Let's see if we can look at what the stresses are. X displacement, stress, Z stress. Yeah, nice. So now we can see all that stress is concentrating where we're actually pulling on the vertebra, and a little bit on where we're constraining it on the bottom, just because the constraints aren't evenly applied. All right, that I think is enough to get started. You can bring in your vertebra and see if you can kind of duplicate this process. Then I think all you need to do is add the additional vertebra and discs and then kind of hone how you're applying this load. But in essence, I think that's how you would apply loads for range of motion.